Hello, students. You are welcome to session 5 of Unit 3. And in this session, we'll be looking at how to measure electrically. My name is Patrick Ej. Now, by the end of this session, you should be able to use electrical instruments to measure voltage and current. So basically, you should be able to use a voltmeter as well as the ammeter to measure voltage and current in a circuit respectively, and also differentiate between a cell and a battery. Now let's look at how we can measure voltage in a circuit. And in order to measure the voltage difference between 2 points in a circuit, then you should wire the leads of the multimeter in parallel with the circuit elements over which you are attempting to determine the voltage drop. Now note that we can make use of a multimeter which can measure current, which can measure the resistance of a material, the potential difference at the same time. Or you can make use of the voltmeter to measure the voltage through the circuit. And to measure the voltage, you must ensure that the voltmeter that you are going to use is wired in parallel with the circuit component you want to measure the voltage drop across. Now, when the voltmeter or the multimeter is being used to measure voltage, the resistance of the device is made very high. And the reason is that so that it will not affect the current flow through the circuit and therefore change the voltage drop. Now we know that resistance talks about the flow, the opposition to current flow in a circuit. And so because we are measuring or we are setting the voltmeter in parallel to the circuit component, we must ensure that the voltmeter has a very high resistance so that current will not branch and pass through the voltmeter. And so this simple diagram shows how we connect the voltmeter to measure the voltage drop across a circuit component. And over here, we want to measure the voltage drop across a battery in a circuit. And this arrangement, so we wire the leads of the voltmeter, so voltmeter or the multimeter. So this is one of the leads, and this is also another lead. One lead to one terminal and the other lead to the another terminal. Now you could see that this is the negative side of the battery and this is the positive. So we have wired the negative terminal to the negative lead and the positive terminal to the positive lead. And this is in parallel to the circuit component. Now, how do we measure current? Now, in measuring current, we wire the leads of the multimeter or the ammeter in series with the circuit element through which you are attempting to determine the current flow. So, whenever you want to connect a multimeter or the ammeter to measure current, unlike the voltmeter where you connect the system or you connect it in parallel to the circuit component you want to measure the voltage drop, in current you have to break the circuit and insert the multimeter or the ammeter in the circuit in order to measure the current through the circuit. And because the ammeter is in series with the circuit, anytime it is being used to measure current, the resistance of the ammeter or the multimeter is made very low so as not to affect the voltage drop in the circuit and also affect the current that will flow through the circuit. So this is a typical diagram showing how the multimeter or the ammeter is being used to measure current through a circuit. So this is one of the leads of the multimeter or the ammeter and the other lead. And you could see the circuit has been broken and the ammeter or the multimeter, or the multimeter inserted in the circuit to measure the current that will flow through the circuit. Now, we must also know that the current that passes through the multimeter goes through a shunt of low resistance that can be used to determine the current flow using Ohm's law. And basically, we know the Ohm's law gives us the relationship between the current and the voltage or the potential difference within a circuit. And the shunt talks about a metallic conductor. So it's a conductor that has a low resistance. And note that miswiring or missetting a multimeter. So note that the multimeter can measure current, it can measure voltage at the same time. And therefore, when you do a miswiring or you do a missetting of the multimeter, it can have a disastrous consequence for both a circuit and the multimeter due to the differences in the resistances of the shunt settings. But fortunately for us, most multimeters are protected with a fuse to limit the current flow. But this is not often the case in electrical circuits to which miswired multimeters are introduced. And for that reason, anytime we want to use the multimeter to measure voltage or to measure current, we must ensure that it has been wired doing the appropriate connection. That is, if we want to take current measurement, it must be in series with the circuit, and if it is for voltage, it must be in parallel to the circuit component. We want to measure the voltage drop. Now, how do we determine the strength of an electrical cell or a battery? But before that, was the difference between a cell and a battery? So a battery is two or more identical cells wired in one of two ways, and the two ways could either be in parallel or in series. So whenever we have two or more cells, we get a battery, and a single of it is called a cell. And when we add cells or batteries in parallel, the battery has the voltage of a single cell, but the advantage is that it can deliver much more current at the same voltage than a single cell. And when we have cells wired in series, or when the cells are connected in series, the battery now has the sum total of all voltages of all the cells in the circuit. Now, most often we come across the relationship V is equal to E minus IR. V is equal to E minus IR. And normally we find it difficult to find the significance of this relationship. So here E represents the electromotive force, V talks about the voltage of the cell or battery, and I is the current provided by the cell or battery, and R is the internal resistance of the cell or battery. And so anytime we connect a multimeter to a cell or a battery to determine its strength, and we know that the multimeter has to be connected parallel to the circuit component, what we actually measure is the E, that is the electromotive force that is passing through, or the electromotive force of the cell, because at that point there is no current that flows through the cell. So whenever a load is applied to a poor cell or a battery, current flows and there is a drop in voltage. And for this reason, normally car mechanics will load test a car battery to determine if it needs to be replaced or not. So under normal conditions, that is whenever we have high current and a low resistance, then the voltage does not drop substantially. Then the difference between V and E is small, which also suggests that there is low internal resistance. And a battery that is good is the one with low internal resistance. So when under normal conditions, that is when there is a high current and a low resistance, and so the voltage drop is not that substantial, it's not that high, then we can say that this battery is having a low internal resistance, and hence it is a good battery or a cell. And as batteries age, their internal resistances also go up. And therefore, the difference between the voltage and the electromotive force grows proportionately. That is, they are almost the same. And for that reason, if you want to determine how much voltage a cell or battery is applying to a circuit, you shouldn't do so by measuring the voltage of the battery out of the circuit. We must always ensure that it is measured when the circuit is complete. When we have a complete circuit that is being operating, then that is the point we can measure the voltage across the cell to find out the actual voltage that is being applied to the circuit. Now, students, in this session, We looked at how to use electrical instruments such as the voltmeter as well as the ammeter, or we can use the multimeter to measure current and voltage, as well as the difference between a cell and a battery. And we saw that to measure the current, we must connect the multimeter in series with the circuit, and to measure the potential difference or the voltage, we must connect the multimeter or the voltmeter in parallel to the circuit component. Now, as we bring the session to an end, let us have this as a take home. How would you measure the strength of a cell or battery? Thank you very much, students, for joining this session. I hope you enjoyed this session. See you in the next session. Bye.